I'm sure you're here today because, like me, you're totally obsessed with trash and AI. And you saw the words trash AI and you thought there couldn't be nothing better to do with my time than watch this video. So thank you for being here. Trash AI is an artificial intelligence algorithm and application for detecting trash in images. You can go to this website, trashai.org, and get started. To get started with Trash AI, you can take a batch of images like this. So I actually collected these photos cleaning up a river nearby where I live. And I took a photo of every single piece of trash individually by themselves. And you can drag. So I've just selected all of these photos, drag them and drop them here. And the algorithm will start uploading the photos and detecting any trash in the images that it finds. And so while that's going, I just want to jump back to the About page and talk about this project. So this project really started in collaboration with Code for Sacramento and in partnership with myself, Win Calgar from the Moore Institute, and Caltrans, who've all collaborated together to envision this project. And Stephen Hollingsworth is the lead developer and contributor to the code base. He is an awesome wizard at making applications like this, and he's done a really amazing job to make this happen. So want to give him a shout out too. Also, Trash AI is really built heavily on YOLO 5 and the Taco data set. So I definitely recommend giving those a check and seeing what great work they've done too. All of this is an open source product. So if you want to take a look at the whole code base, you can, and you can contribute to the code. We're always looking for more contributors. And we're going to have a software manuscript coming out about this application pretty soon too. So that's really exciting. So you can see here, this is currently uploading. We're using IndexedDB to do this. It's actually storing the images in your browser, not on a server. And that's really the magic of this this application, because we're not running all of these operations on our server where we're incurring some huge fees. You're actually when you go to this website, you're running the AI algorithm on your own computer. So that's one really exciting part of this. It allows us to really scale this application and provide AI to everyone, really. So that's really the big goal of this. A little bit more about these images. So we had 274 images here. I typically, when I'm doing trash analysis, I'll take photos like this of the trash, and then I'll pull up a spreadsheet and I'll go through every single photo and characterize what's in the photo, what kind of trash it is. And the algorithm is really just doing that all for me, instead of me sitting here and painstakingly going through a spreadsheet. I can just let the algorithm do the work, and I can have fun making this video instead. And we're already halfway there. This 274 images would usually take me an hour or two to process all of the information in there, and the AI algorithm is going through and doing a lot of the heavy lifting for me. One of the cool things that we can do with this app is that even though it's not fully finished yet, we can already start to go ahead and look at some of the images that are coming in and some of the data. So we can take a look at this image here, for example, and it's found a piece of trash over there. One thing that I'd like to note definitely right away is that it's not detecting every single piece of trash yet in images. We still have some work to do to improve the AI. And on the back end, we are saving some of the images and annotations so that we can improve the artificial intelligence algorithm in the long run. So really appreciate people using this app and helping to contribute to make this AI better. We would love to have more AI contributors that are experts in making these algorithms more accurate. And you can also see metadata for the image. here. So this is all the image metadata. So it actually pulls out the lat-long coordinates. It pulls out the timestamp. And then now, since it's found trash, it has metadata associated with that trash. So there's a bounding box coordinates, width, the height, an accuracy score, and then what classification the trash is. And then you can also look at it on a map. So here we can see the location where the trash is. And I think this map is even, not this map isn't selectable, but then the other map. So there's a summary tab here. And so the algorithm has already completed all of the tasks. So it did it way faster than I could, and it was zero effort for me. So that's really exciting. Now I just got to go through and QA QC what the algorithm has put out. So we can take a look at the whole batch summary here in the map. This is the little reach of river that I cleaned up. These are all the pieces of trash that I found. You can see some of my GPS coordinates were a little bit off from my cell phone. I was in like a deep channel there, so that kind of makes sense. Also, you can look at images. So there should be 100% of these images should have trash in them. But there are several. It looks like about somewhere around a third or fourth of the images haven't had any detections from the AI. That just means that the AI didn't see any trash in them. So that kind of gives you an idea about where the accuracy is at right now. It's kind of hard to pin down like an exact accuracy metric on some of these things, but and then you can see the detections. So you can see a vast majority of the trashing in the images was plastic film. This is a hierarchical model. So we actually have classifications like unlabeled litter, which are like higher orders of classification. Other plastic wrapper, styrofoam pieces. You can click these and quickly see. So it will show us all of the images that are of plastic film. And so you can go through and QA QC the images like this. You can look at the unlabeled litter. Yeah, tons of good stuff there. All right, so couple other cool things I'd like to show you before we log off here. We can toggle light and dark mode. I usually like to work in dark mode primarily, but I just wanted to keep it as the default just so that people would be familiar with what it looks like. You can also go to Code4Sac homepage here and learn all about the great work that the Code for Sacramento group is doing. They are really an amazing group of developers and human beings that I really enjoy working with. And I've really been inspired by the kind of stuff that they're able to do with these web apps. It's just amazing that they've been able to create this. This is something that that industry has been working on for a long time and hasn't solved, and a group of pro bono coders has been able to make this a reality. So really exciting. So all right, so I have all of my data, right? I have uploaded all of my photos. Now I want to download a batch data set. So you can click download all. And what that's going to do is it's going to create a zip file full of tons of good data. All of the annotations, all of the lat long coordinates, some summary data. While that's getting going, we can take a couple looks at some other cool stuff here. Got some drink cans. Super interesting. Some glass bottles. Bottle caps. Yeah, definitely some room for improvement in this in the AI algorithm. It's really hard to make a general AI for trash, but we're making some really big steps here. So I'm going to extract this so that you can take a look and see all of the great data that it compiles for us. This data set is really going to be kind of a, one batch download to rule them all kind of data set. It just gives you like all of the information you could possibly want. And we realize that that may not be the most readily accessible format for a lot of folks. So if it's not for you, then please let us know. We're happy to take recommendations on how to improve this tool. So taking a look at the data here, so we have the image of the trash, we have the metadata associated with the trash, and then if there's any bounding boxes, there's another image here of the bounding boxes. Toward the end, there is a summary file, which has summaries of all of the trash from all of the images. So you can take a look at that. And we would love to get your feedback on this, things that you think we could improve. We'd love to have more collaborations with other folks who want to help make Trash AI, the future of trash management, trash data collection. I think there's a ton of applications for this, everything from street sweepers to cleanups to, looking at Google Street View for trash. I mean, it's really limitless here. So thank you so much for joining, and looking forward to hearing from you.